thing I love most about robotics is the challenge of figuring out what makes things function intelligently in the world. Sensing and control, mechanical design. How do we control the robot fingers so that they're able to achieve some of the dexterity that people can achieve? And robotics at Harvard has had a wonderfully experimental flavor. We build things and test them and make them work in the real world. It's not just a theoretical exercise.
Soft robotics is an emerging field within robotics. In this lab, we essentially say that there's a huge opportunity to apply small to moderate levels of assistance to people. You don't need to give them superhuman strength, but that in itself can have a pretty big impact in terms of their mobility and quality of life. This could be people who've suffered a stroke, it could be elderly people, children with cerebral palsy. So we're trying to think about how do we develop new types of wearable technologies that allow them to move around more naturally like a healthy person.
What we're trying to do is make robots smaller, softer, safer to interact with, more effective because of they're either more agile or can maneuver in places that big bulky robots wouldn't be able to do. Example applications include search and rescue, hazardous environment exploration, biomedical applications, things inside the body, things where you wouldn't want to put a human or an animal.
One of the applications that I'm really interested in is whether you can get robots to construct things for us. Ultimately, what would be really cool is if you had a disaster area or there's a flood, and instead of sending a bunch of people into a dangerous area, you sent a bunch of robots and they picked up the sandbags and they made walls and levees. You can't make a robot unless you understand mechanical engineering, electrical engineering, computer science, and then it actually helps to understand biology because biology is the best examples of autonomous systems. I do try to work closely with people from many disciplines. In fact, that's what I like a lot about being at Harvard, is that that's so easy to do.
It's a great place to find academic collaborators and certainly medical collaborators as well.
Key benefit of SEAS is that although we're growing, we're still somewhat small. That makes us very nimble, very agile. I mean, we can put together interdisciplinary teams very quickly.
We've really reached an important cusp in robotics. There'll be any number of important applications in industry, households, hospitals, factory floors, all sorts of new places.
Almost every application will have multiple robots together.
Assisting with tasks that are difficult, dangerous, extraterrestrial, whatever they are.
The number of robotic startups taking the ideas from research, turning them into practical applications is skyrocketing, and we're very excited to be part of that.
If you think about the last 20 years, the internet has really transformed our lives and the way society works. But going forward, I think robotics is going to be playing that big a role.